Good day, everyone. Today I will be discussing to you what is electrophorus. So the electrophorus in electromagnetism, an electrophorus or electrophore is a simple manual capacitive electrostatic generator used to produce charge via the process of electrostatic induction. A first version of it was invented in 762 by Swedish professor Johann Carl Wilck. So one of the largest example of an electrophorus was built in 1777 by German scientist George Christoph Lichtenberg. It was 6 feet 2 meter in diameter, with a metal plate raised and lowered using a pulley system. It could reportedly produce 15-inch or 38 centimeter sparks. The electrophorus simply separated positive and negatively charged. A positive or negative charge ends up on the metal plate or other storage conductor, and the opposite charge is stored in another object after grounding, in the earth or the person touching the metal plate. So let's proceed to the next slide. A commonly used lab activity that demonstrates the induction charging method is the electrophorus lab. So observe the illustration. So in the diagram 1, a foam plate is rubbed with far and given a charge. So in the diagram 2, an aluminum plate is brought near the foam, inducing E movement to rim. So in diagram 3, when touched on the rim, E moves through the hand to the ground. In diagram 4, the aluminum plate having lost E now has a positive charge. And the last diagram 5, remaining E move around until the positive charge redistributed. So let's proceed to the next slide. The electrophorus law further illustrates that when charging a neutral object by induction, the charge imparted to the object is opposite that of the object used to induce the charge. In this case, the foam plate was negatively charged and the aluminum plate became positively charged. The lab also illustrates that there is a never transfer of electrons between the foam plate and the aluminum plate. The aluminum plate becomes charged by a transfer of electrons to the ground. So that is electrophorus. And now, let's proceed to what is electroscope. An electroscope is a device that is capable of detecting the presence of the charged object. It is often used in electrostatic experiments and demonstration in order to test for charge and to deduce the type of charge present on an object. So what is the uses of electroscope? So let's talk about it. So it is used to detect the static charge, and the nature of electric charges can be determined using an electroscope. The magnitude of two different charges can be compared using an electroscope. There are two classical types of electroscopes, and they are the follows. The pith ball electroscope. So what is pith ball electroscope? It is invented by John Canton in the year in 1754. It consists of one or two small light balls that are lightweight, non-conductive substance called pith. And next is the gold leaf electroscope. This is the second type of electroscope. So what is gold leaf electroscope? It was developed by Abraham Bennett in the year 1787, which is more sensitive than pith ball electroscope. So it consists of a vertical metal rod with two parallel stripes of a thin, flexible gold leaf hanging from it. So that is the uses and the types of electroscope. So next slide. Another common lab experience that illustrates the induction charging method is the electroscope lab. In the electroscope lab, a positively charged object such as an aluminum pipe plate is used to charge an electroscope by induction. So observe the illustration below. So as you can see in diagram 1, this is a illustration of a neutral electroscope. In the diagram 2, the positive aluminum plate attracts E from the bottom of the E-scope to the top plate of the E-scope. In the diagram 3, when touched, E enter from the ground to neutralize the positive charge in needle. So in diagram 4, the E-scope has charge. This negative charge is still located in the top plate. In the last diagram, the excess electrons redistribute themselves. So that is the diagram that you need to be observed in electroscope. So let's proceed to the next slide. So the discussion provides one more illustration of the fundamental principles regarding induction charging. These fundamental principles have been illustrated in each example of induction charging discussed on this page. The principles are: first, the charged object is never touched to the object being charged by induction. Second, the charged object does not transfer electrons to or receive electrons from the object being charged. Third, the charged object serves to polarize the object being charged, transferred between the ground and the object being charged either into the object or out of it. Lastly, the object being charged ultimately receives a charge that is opposite that of the charged object that is used to polarize it. So that is the electroscope all about. So let's proceed to the next topic. So let's talk about what is charging by conduction. Charging by conduction involves the contact of a charged object to a neutral object. Suppose that a positively charged aluminum plate is touched to a neutral metal sphere. The neutral metal sphere becomes charged as the result of being contacted by the charged aluminum plate. Or suppose that a negatively charged metal sphere is touched to the top plate of a neutral needle electroscope. The neutral electroscope becomes charged as the result of being contacted by metal sphere. So what it is all about? So charging by conduction refers to the technique of charging an uncharged material by bringing it into touch with some other charged material. A negatively charged as well positively charged item seems to have an even amount of charges. For example, if a neutral glass rod is vigorously rubbed with a cloth, the cloth can remove some of the outer electrons from the rod, leaving it with a net positively charged. So let's proceed to the next slide. In contrast to induction, where the charged object is brought near but never contacted to the object being charged, conduction charging involves making physical connection of the charged object to the neutral object. Because charging by conduction involves contact, it is often called charging by contact. So the major difference between conduction and induction is that conduction allows the charging of a neutral body with a charged body by forming a direct contact with it, while induction is the process of charging a neutral body by a charged body without making any direct contact. So that is charging by conduction. So let's proceed to the last topic, which is charging by conduction using a negatively charged object. So a negatively charged metal sphere has an excess of electrons. Those electrons find each other repulsive and distance themselves from each other as far as possible. The perimeter, the sphere, is the extreme which they can go. If there was ever a conducting pathway to a more spacious field of real estate, one could be sure that the electrons would be on that pathway to the greener grain grass. So observe. The diagram 1, a metal sphere with an excess of negatively charged is brought near to a neutral electroscope. While in the diagram 2, upon contact with E move from the sphere to the electroscope and spread about uniformly. In the diagram 3, lastly, the metal sphere now has less excess, negatively charged, and the electroscope now has a negative charge. So during charging by conduction, both objects acquire the same type of charge. If a negative object is used to charge a neutral object, then both objects become charged negatively. In order for a neutral sphere to become negative, it must gain electrons from the negatively charged rod. A charged object has an unequal number of negative or electrons and positive charged protons. Hence, when a charged object is brought in contact with the uncharged conductor, the electrons get transferred from the charged object to the conductor. So what happened if when you touch a negatively charged object with your hand? So human body is a conductor of electricity. So kabalataan na. So when we touch a charged object, our body conducts its charge to the earth. That is why a charged body loses its charge. If we touch it with our hand, the phenomenon is known as earthing. So thank you for listening. That would be all. Thank you. I hope you can get helpful knowledge from this presentation. Good luck. Thank you.